journey started at the Mayo Clinic. I was doing a postdoc in protein biochemistry after studying reproductive biology in grad school, and realized that it wasn't for me, and I was lucky enough to find an opportunity to get into IVF and actually use the things that I really was passionate about through grad school and apply it to help people. So it was a big turning point for me at Mayo Clinic. So I started in private practice then in the mid-90s and spent about 10 years in small private practices throughout the US. And I saw many inefficiencies in the way we do IVF and how we help patients. And what I realized was that there were really a lot of areas that needed improvement. So then I went back to the Mayo Clinic in about 2005 and was able to start doing research on methods of improving the quality of the process to actually make the process better and have better outcomes. So that was kind of the driving passion for me to say, okay, research-wise, how do I help this process, and things that I see in the day-to-day operations, how can we make it better? So I've been successful in identifying areas that could be improved and how to improve them. They're small incremental advancements. There's other amazing changes that have occurred in the last decade or even almost 20 years now that have really changed the face of IVF. One being blastocyst culture, the fact that we can get much better selection by going to day 5 for the right patients. Though there are some patients that still benefit from cleavage stage transfers when they only have a couple of embryos, because we're still not as good as the human body to make embryos grow all the way, and some patients are going to benefit from an earlier transfer. So that's one advancement. Another advancement has been, well, even before that was the introduction of ESHRE, so the ability to inject sperm for guys that have no sperm or very few sperm. That was a huge advancement in the 90s. And then more recently is our shift to using vitrification. So the method of freezing eggs and embryos has improved to the point where it works just as well as fresh embryos, basically, and almost as well as fresh eggs. And the egg story is one of the most amazing ones because it's great for fertility preservation, but it's also something for women who aren't ready to have their children and want to preserve their fertility. It's really working well. No, really not. There's really not much difference across the board. We really see that, I think it's one of the worst things that can happen to a young couple or any couple is, facing infertility when their life streams of coming together. It's really a unique thing that, when you look at our biological drive and our societal pressures to have children, that it's such a burden on patients. It's the same all the world over. There are some differences here and there, but for the most part, it's really happy couples wanting to have a baby. So that really isn't very different. It's a good question. I think because it's expensive, because it's invasive, it's not fun. It's never going to really catch on for people to want to do it if they don't have to. I think that there's maybe someday way out in the future where there's such a benefit from going through an artificial process for selection purposes, which is scary, and I prefer not to imagine that day. But for now, I think that the majority of people want to have a baby on their own, the old-fashioned way. And so I don't see an increase because of this. There's the odd occasion where you hear about someone who doesn't want to have a pregnancy because they may have some reason why they just don't want to alter their body. Those kind of rare things, but for the most part, no. It's all driven by people who innately want to have a child on their own but can't. Yeah, I really struggle seeing it becoming that because it's always going to be, invasive. It requires a couple to come together and to talk to a stranger about their intimate life and then have it controlled. So I think we're pretty far from having to worry about how to keep that from creeping to become more common that people want to do this, say, for genetic reasons. That's a ways down the way, and I think even once it becomes possible to do more genetic testing and screening, that it's still not going to be popular because it's expensive and not fun. Yeah, we've been growing quite a bit in New Zealand and in Southeast Asia in particular. So our our scope is really changing in that we're adding more different types of treatments like PGT, so preimplantation genetic testing. We've been adding more of that. We're also doing more time-lapse imaging. So those are some advancements where our scope is expanding. The scale is increasing mostly from our expansion into Southeast Asia. So we have several clinics in Malaysia, and we're looking to grow continuously in that region because that's really where the growth in the field is happening at the time. Yes, yeah. So when you see their GDP and just the way that those societies are growing, those countries, they have more people that are able to afford IVF, and therefore the demand is higher. So my talk that I gave on Sunday was about culture media and whether there's differences in the culture media that's used and what's the performance. And the theme there was that really we don't know how well the different culture media do because there's not good studies on it, but we expect that we can do better. That we still have a challenge with infertile patients giving us deliveries of babies that are on average lighter, and we don't know why, and we have to continue to look at our systems to see what could we be doing to contribute to that. It could be inherent, it could be, there's many different factors involved. So my talk, my theme was really saying what's the culture media, what are we feeding the embryos, how can we improve that, what are some differences that may make a difference in terms of outcomes. Yeah, so what we really need in the area of culture media is we need more randomized controlled trials comparing two culture media in several clinics in a really controlled manner so we can see is there a difference not only in live birth but also in birth weights and the neonatal outcomes. We have very few of these studies that have been done, and they're really not that difficult when you compare them to other randomized controlled trials, so laboratories could be doing more of these, and we're looking forward to doing one in New Zealand. Yeah, so in the area of culture media, it's really complex. So we're talking about 40 or more nutrients in the complex media, and they're all at different mixes. So it's so complex that we can't say, let's compare this one ingredient to this one ingredient in another culture media. No, we have to compare one whole culture media to another one, and it's like comparing Coke to Pepsi, and we don't know what's in them, and so we can't really make good comparisons. We need to really say, well, let's take Coke and just change one thing in it, and so it's more controlled. And then when you add in the different clinics and the different conditions that they use, it becomes so complex that it's really difficult to answer that question. So I'm always aware of external factors that can impact the culture systems that we're using, and really the number of them is also an endless list of things that could come into play. The air quality, the dishes that we use, the quality of the incubators, how we handle the dishes as we work, the quality of the different ingredients in the solutions we use. So there's so many different things. If I had to pick one just to highlight right now, I think there's more awareness around air quality. So when we talk about air quality, we think of two things. We think of particles that could come in and, say, cause a contamination. We also think of volatile organic compounds, so VOCs, smells and things from, say, diesel fuel or exhaust, and that these are the bigger concern. And what we just, I was participating with a consensus document on air quality in IVF labs, and we published that just in the last couple of months, and that really is bringing more attention to the need for good air quality in IVF labs, because it's a central tenet to having really a good system for growing embryos. Yeah, so air quality, we know it differs from within cities to outside the city. So like air pollution in different cities is clearly going to impact air quality. But there's no definitive studies to show the impact on IVF outcomes. There are some really good studies recently showing that more air pollution is actually associated with more infertility. But it's really difficult to bring it all the way to the level of the IVF lab. There's some more anecdotal, and then there's one really good study that was published that showed an impact of not having good air filtration and how it But regionally, no, we don't really have much evidence, although I will say in New Zealand we have amazing air because we have the nice sea breezes coming, so there's very little pollution. Time-lapse is a favorite of mine. Any embryologist that's used time-lapse imaging is a huge fan because it just intuitively makes sense to culture embryos where you don't disturb them, you leave them alone, but you get more information. You get to see what they're doing and you're not disturbing them. And you're actually exposing them to less light, by the way the system is designed, than if you took the dish out and looked at it every day. So it's really an incredibly safe approach to get more information and handle embryos less. The area around selection has been a hotly debated topic, and it's one that a lot of people are focusing just on that. And if we look at only, does it let us pick an embryo better? It does, but on a very small scale, such that you don't pick it up in large studies. Studies don't show a huge benefit, and so there's a lot of criticism of time-lapse. But in actuality, there's little incremental gains that we get from it, and it can really matter to a patient. Let's say one example is that an egg fertilized early. Normally we see an egg is fertilized and we can look at them at 18 hours after we mix them with sperm, and we can see that it's been fertilized. Sometimes that evidence of fertilization is already gone at 18 hours. And if we missed it, we would say, oh, it didn't fertilize, and now that's not in the equation anymore. With time-lapse, we're actually able to see that, we capture that without having to come in at 4 in the morning to see, oh, maybe it was fertilized early and I didn't see it. So that's a benefit that is hard to quantify, but for a patient that only has 2 or 3 eggs, that could be the difference between getting an embryo or not. And those don't show up in big studies. So that's a really important benefit of time-lapse that, and there's many small ones like that. Where I see the biggest gains coming are the fact that we have this incredible platform, an incredible amount of information that now affords us the ability to apply things like artificial intelligence and machine learning to say, take the information we're getting more information that we as humans can process and figure out. Let's let machines figure it out. Let's let computers really look into this. And we think we could have much better selection through that. And there's some exciting abstracts at the meeting this year and other work that's being done that says that that's probably going to be the way that time-lapse will really take us to the next level. So time-lapse cost is an issue because it is an increased cost to the laboratory to purchase the equipment. And there's been a reluctance for clinics to buy that equipment because of that cost without strong evidence saying that it's going to be significantly better. All of these other incremental gains, small gains that we see, in addition to some efficiencies and better probably patient experience, because the patient gets to actually be more aware of what's going on in the laboratory and has the comfort of mind of knowing that their embryos are being left alone. That these are values that you can't really put a monetary amount on. So there's been a reluctance to uptake it in the US for sure. In Europe it's been gaining traction, and it's really just a matter of time. We're kind of working with 20th century technology for the most part, using incubators that were designed really for cell culture back in the 20th century. And we're still using them because they work well, and we're reluctant to invest in new technology. And I like to just say, there's an analogy that I use often, which is, Louise Brown was born in 1978, which is about the same time as Apple Computer. And when you look at the rapid advancement of Apple over that time and all the innovations, and it started out with a desktop computer that evolved into a handheld device or an iPad, and all the applications that go with it, the ads that came into it later, the add-ons, were just incredible. And we would never have forecast that in 1976 when Apple started. We had no idea that it could have exploded into this realm. The same is true with time-lapse. We need to have the system, this whole new paradigm shift in how we culture embryos that will allow us the ability to then do many other things that we just aren't even capable of imagining at this point. So the best way to get to that point is just, one thing is we've been limited. There's an interesting business story behind time-lapse in that there was one company that came out with it in 2008, and then there was a patent issue in the US that slowed its advancement. There was no competition until recently, so in the last 3 or 4 years we've now got 3 units on the market. So when you look at it from a supply and a competitive marketplace, we haven't had that. And so we need more units on the market, which we now are getting to that point. That's going to hopefully drive down the cost a little bit, but also give clinics more and more options to choose. And it's just a matter of time for clinics to completely switch over to time-lapse. I don't think there really needs to be much other sort of business initiative to do that. I think it's just a matter of natural evolution of technology. We have to be careful when we're looking at technological advancements, because we know that patients are vulnerable. They want to do whatever they can. They're looking for that silver bullet to make a difference, and it's a challenge. So we have to be careful. We have to be guarded. Yet we also want to advance things, and there are, I think, we just are scratching the surface when it comes to the use of things like AI and other computerized methods to really advance our field. As well as gene expression use, there's a lot of advancements that we see on the horizon that will benefit them. Ultimately, though, we're still limited by what the quality of the gametes are that we start with. So if we can't improve the quality of the gametes, then we're not going to be able to advance that area for that set of patients. But we can definitely continue to advance how well we handle the ones that do have the potential to implant, and then also improve our ability to choose the best one fastest, so that we limit how much a patient has to go through to get to that baby. So I'm going to continue with the theme of time-lapse and artificial intelligence. There's some really good sessions on that, or at least I hope they're going to be good. We'll find out. We haven't gone to it yet. And I just came from a really outstanding plenary this morning talking about the genetic screening approach and whether it's the best answer for patients with few embryos. And really the answer that I've felt all along, and the way we practice in New Zealand, is that if a patient only has a couple of embryos, there's really no point in subjecting them to a test that is not perfect, and thus has the potential for embryos not to be transferred when they are actually viable. So we don't want to lose those embryos, and really the technology of PGS or PGTA is not quite up to the par of what we need it to be, and not because it's a bad technology, it's just because the system is human, and it's got variability that we can't account for. So really the answer there is, with patients with few embryos, there needs to be some really exceptional circumstances why they really need to have the embryo screened for the correct chromosomes. So that was a really good session. The two limitations that we have, again, are that we need to have good gametes to make good embryos. We figured out ways, like with ESHRE, to actually help them get together, so that's been great. We've got better culture and better freezing systems, so we have ways to preserve what we end up getting in the lab. We're kind of reached what we would say is the glass ceiling of fertility care, because we had to stimulate a patient to get a lot of eggs to really condense a year's worth of ovulations down into one event, so that we could have a better chance of picking one that was going to make a baby. So that was a big advancement in the 70s and 80s. Then we saw that doing ESHRE got more guys involved that weren't available before. We still have the limitation that if a patient makes eggs or sperm that aren't compatible with implantation, we don't have much we can do there. That's a limitation. But from here, it's now saying, how do we choose the best embryo fastest? And so it still goes back to these issues of, well, we can use invasive methods like preimplantation genetic screening, or we can look for more non-invasive methods like this artificial intelligence for measuring blastocyst quality. It's a challenging place to be, I think, as a patient in this world, because we rely on word of mouth to see doctors. We rely on what we read online. The limitation is what's the nearest information and what's the most influential information for that patient. So there's the risk there that some patients are going to be in a place where they're not necessarily going to have the best information, or they're going to go to a clinic that's not necessarily taking the most evidence-based approach to care. Where there's promises online, there's incredible resources that provide just an amazing wealth of information for patients to be able to get good scientific-based evidence to make decisions. it's daunting because it's a very technologically, complex field, and for a lot of patients, it's more than what they really want to have to think about. So that's one of the challenges. So taking this information to a level for all patients is really one of the challenges, and some of these advocacy groups are doing a great job of putting good online content out there.